In this video we are going to learn how we can use this WH532 MOSFET with optocoupler controller to control a load or control a motor, a DC motor with speed control. D4184, LR7843 and FR12N MOSFET. This video I'm going to explain the module under the magnifier. After that I'm going to show you the schematic and then wiring, how to connect it to the battery without a battery, the same battery to Arduino. Then I'm going to provide you 3 types of code. First, I'm going to show you how to turn it on and off as a just on off without speed, so we can test it and see how it works. Then we are going to control the motor with Arduino with a speed control and stop it. After that, the third project will be push button and variable resistor or potentiometer, where you can start and stop the motor and also increase or decrease the speed of rotation of the motor. So, hi, welcome to an Arduino step-by-step course by RoboJax. This module is sold with 3 variations of different types of MOSFET that is available there. D4184, LR7843 and FR12N MOSFET. Each has different characteristics for different amount of current, so we can control a load or a motor. If you're controlling a motor, you cannot change the rotation and direction. You can just control in one direction, but if you're using Arduino, we can control the speed of the motor. Now, we don't need Arduino. If you just connect these 2 pins, it says ground and pulse width modulation. If you connect it to 5 volts, the motor or the load that you have will be turned on and off. But for the speed, we need pulse width modulation or PWM, where we use this Arduino to generate it. But you can use the pulse width modulation module that is sold on AliExpress and eBay. I'll try to provide you the link below the video. You can connect that here and control the speed of motor, or you can use 555 timer to control the speed of the motor. The MOSFETs that are used here can go from 9 ampere to 60, even 160 ampere. But this is not practical with this. You need huge heatsink which cannot fit here. So this is just for a lower current up to 3 to 5 ampere. But if you're going with higher current, then somehow attach heatsink here. And I'm going to show you which one has higher current in the detail and explanation. But keep in mind that you can control up to 30 volts with these modules. If the motor is up to 30 volts, you can control it. And here is the schematic. We are connecting our motor at this terminal where the positive goes to the motor, the negative of the motor comes back and passes through this MOSFET. This MOSFET can be any of these 3 different types. And this side is connected to the ground, and this will act as a switch in order to turn this on with proper voltage, because we have higher voltage, let's say 30, 40, whatever voltage that we have based on the motor. If the motor is 12 volts, you will connect 12 volts, whatever it is. So the voltage will come to this optocoupler. It has 4 pins. On one side we have phototransistor, the other side we have a photodiode or just diode. It receives voltage. When the voltage is received, this is turned on and the current passes and the energy comes to the gate of this MOSFET and it will turn on here. So now if we replace it with a switch, right now the switch is off when there is 0 volt. When we have 0 volt here, then there is no voltage. This is off, and as a result this switch is off or disconnected. So the positive comes to the motor, but the negative is not connected to the ground and the motor is off. When we have 5 volts here, then this will turn on this phototransistor and the current passes and the switch is connected, and the positive comes to the motor, the negative is connected to the ground, and the motor will rotate. So this is very simplified explanation of this circuit. Let's have a look at the components under the magnifier. The first piece on this side, this is the optocoupler PC817, and then this is the main MOSFET. This one is D4184. The other one is LR7843. The third one FR120N. The rest of the components are exactly the same. If you're controlling a DC motor, then make sure to connect a diode here between this positive and negative. The line that is there, the cathode, should be connected to the positive and the anode to the middle. If you're connecting a motor that needs 2 ampere, and if you're using this 4007 or 4001, 1 and 4001, then for each ampere connect one diode. So if it's 2 ampere, connect 2 of this in parallel. If it is 3 or 4, connect 3 or 4 in parallel and twist them like this. So this way you don't need higher current diode. Now let's have a look at the data sheet for D4184. This MOSFET has the drain source voltage of maximum 40 volts and the maximum current of 50 ampere at 10 volts. Drain source resistance at 10 volt is less than 7 milliohm, and at 4.5 it is 9.5 milliohm. And the data sheet for 120N, the drain source voltage can go up to 100 volts, but the resistance is very high. The drain source resistance when it is turned on is 210 milliohm, and drain current is maximum 9.4 ampere. For the RL7843, the drain source voltage is 30 volts and drain source turn on resistance is 3.3 milliohm. This is very low. And in order to understand which one is suitable for your application, LR7843 or FR120N or D4184. So this is the drain source voltage, or the voltage that you are connecting to your motor or the load. If you select this model, it will be 30 volts, and then we have 100 volts or 40 volts. But this is not the important factor only. Another important factor is the amount of current. With this model, you can get at 25 volts 160 ampere, at 100 degrees Celsius 113 ampere, and for the other one 9.4 or 6.4 ampere, and for 4184 you get 50 or 40 ampere. So if we go with the minimum, it will be around 100 ampere or 6.6 or 40 ampere, depending on these that you select. But all of these will work with 5 volts with Arduino will be turned on. So don't worry, you can connect your motor that is let's say 5 volts, 12 volts, whatever voltage that you have, it will work. But this RDS on, when the drain source is on, this is the resistance that is created. This is the ohm value of drain source. So the MOSFET acts as a resistor. So this is 3.3 milliohm, which is the smallest one, and this is very high, so it has a lot of waste. This is relatively good, about 9.5 milliohm. So if you are going to select, this will be the best one because it has the highest efficiency. And here I have plotted this using a spreadsheet, and I put here the RDS on for each device, and this is the plot of energy waste in power. This is in power in watt, and in horizontal we see the current. And for the red one is FR120N, as you can see. So with this one you can go up to around 9 ampere, but around 17 watt is being wasted, and this has the lowest quality. But if we go with this one, this is the highest one, the blue LR7848, up to even 60 ampere. Here I have drawn because you could go higher. And also for this one, which is 4180, the 60 ampere, you are getting around 26 watt waste. And then for LR784, when I extended the amount of current, even if you go up to 100 ampere, then the waste is, as you can see, about 40 watt, but for 100 ampere you're wasting at about 35 or 33 watts. Now here is my wiring. I've connected 3 wires. This goes to my power supply, 9 volts, 12 volts, whatever I have, and this goes to the, so this goes, 2 of these will go to the power supply, and this is the negative for my motor or load. So this negative is coming, passing through this MOSFET and exiting. For my Arduino, I'm just testing it with pin 2, setting the pin 2 to high, and this is now continuously outputting 5 volts. Let me just connect it here, ground to the ground and positive to positive. Now pulse width modulation pin is connected. Here the red is 5 volts and that's ground. Now we don't have any power. Let me connect my power here. This is my power supply, positive and negative. And as you can see, the light is on and the output is on. So if I disconnect this, the output is off, connect it back, it is on. And here is my motor. These are the 2 wires for the motor. The model for the motor will be on the resources page, the link is below. So this is a 12 volts and I'm connecting it with any voltage I want less than 12 volts. So the 2 wires from the motor is connected like this. This is the power supply. I'm connecting positive to the positive. So this is connected. Now the negative of the motor will be connected to the middle wire. Now if I connect it, it will be turned on. So let me disconnect this. Here is very basic wiring. If somebody doesn't know, this is not connected, the pin. The motor has power, it's not on. As you can see also, this light is off. So I have to hold this, or maybe reduce the voltage so it doesn't jump. So it is off and on. So this is just turning it on and off. So you can remove this motor, connect a load or whatever you want to turn on and off. Here is very basic wiring if somebody doesn't understand the schematic. So you have a battery. Let's assume your motor is 12 volts, then you use 12 volts battery. If your motor is 36 volts, then you use a 36 volt battery. But because this is 12 volts, I've connected this positive and negative directly to Arduino to power this app. And this is very convenient. Otherwise you can supply separate voltage. So we are connecting it, and positive goes to the motor, negative from the battery goes to the last terminal. The middle is connected to the other terminal of the motor, to the negative terminal. Keep in mind that this is negative. So this negative comes and goes through MOSFET when it is turned on and comes back here. For the signal, this side is pulse width modulation. They put this connector reverse both of these. This should be the other way so we can see the hole. But anyways, I'm using pin 3. Pin 3 will be connected to this pin. Make sure to connect this to the negative of the motor. And here is the code. I've defined here a motor out pin as pin number 2. And this is just for a serial monitor. In this line we say pin mode, pin motor out pin as an output. So this is selecting the pin as an output, and then immediately I'm writing digital write motor pin high. So this is turning that pin with high, which means 5 volts. There is nothing else in here at the loop. Here is the second code where we can control the motor using Arduino without anything external. It's all being controlled from Arduino. First, the motor pin is pin 3, and we set the speed minimum and maximum. For some reason, in some applications, people don't want to go, let's say, 80% or 90%. So you can set your minimum, for example, 20 and maximum 80, whatever you want, but not beyond 100 and beyond 0. So this should not be less than 0. This cannot be over 100. And stop and start, do not change them. These are used inside the code. And then motor state, so below this, do not change. And to control the motor, we say motor control 50. So this run motor with 50%, and then we wait. In this case, delay 5000, keeps it waiting for 5 seconds. And then if you want to stop the motor, just say stop motor. Of time, whichever amount of time you want, you can stop it. If you want to go motor to go with 100, just type 100 like that. So this code is now uploaded. Here is now the demonstration. The code have been uploaded. It's running. The light is on, 5 seconds on and 3 seconds off, as you can see. But the motor does not have power, so let me connect it to the power. Because the motor is off, now it will run and stop for 3 seconds. So let me make this 100% and upload the code. It's uploaded. Now it's 100%. This motor needs 12 volts, so let's make it 12 volts. Now I've set it to 12 volts. Now I've changed the code so it can increase the speed slowly and then decrease it slowly. Let's test it. So now it's slowing down. So 50%. So this is slowing down. So disconnected it. And now I'm going to show you how to control this motor with potentiometer, the speed of this motor, and a start and stop push button. And here is the wiring diagram for HW325 MOSFET with push button switch and potentiometer. The potentiometer can be between 1 kilo ohm to 100 kilo ohm. Even 1 mega ohm or 500 kilo ohm will be fine. It's not critical. If you go below 1 kilo ohm, you will just increase the consumption of current. So it's better to use higher value. And for this one, the left pin is connected to 5 volts. Very important, the middle is connected to analog 0. So the middle must be connected, otherwise this will burn if you connect it between ground, the middle pin between ground and the other one with the 5 volts. So the first one goes to 5, the last one goes to ground, and the middle goes to analog 0, where we read the value when we rotate this variable resistor. For this switch, this is push button switch. You can use any other switch you want. One pin is connected to the ground, the other pin is connected to pin 4, where we define in the code. You can define any other pin. For the HW325, ground pin is connected to the ground of Arduino, and the pin that is labeled as pulse width modulation is connected to pin 3. Make sure to connect this or define it in the code, the pin that has this tilde, 3 for example, 5, 6, 9, 10, 11. If you connect it to any other pin without this tilde, the pulse width modulation will not work. For the battery, we are connecting the battery is 12 volts, the motor is 12 volts. If your motor is 18 volts, 30 volts, the battery should be 30 volts. So whatever is the voltage, the positive is connected to this pin on this side, and the same connected to the motor. The negative of the motor is connected to the middle pin. This is very important. And the last pin is negative. This is connected to the negative of the battery. Because this is inductive load, we have to connect here a diode between this pin and the positive, like this. So the side that has line will be connected to positive, and the other side will be connected to the negative. So you will protect the module. Let me now explain the code. The code with potentiometer and push button, we define a potentiometer pin which is analog 0, and define a motor output pin, pin 3. This is a pin that has this tilde beside the pin, so it's pulse width modulation enabled pin. And then start stop push button, pin 2. These are minimum and maximum. You can set to prevent the motor not going beyond the values that you set, but beyond this, do not change it. So we press the push button, motor starts running, and you can control it. Press stop, press, motor runs, press stop. There is a 300 millisecond delay to detect the push. Now if I turn it on, now it's around 50%. So let me reduce the speed. So depending on the motor, some motor runs at very little amount of energy, some with more. Now it's 100%. If I want to stop it, it stops. Now because the speed is set at 100, when I turn it on, it will go to 100 because the knob is at the maximum. Stop at 21%, and then if I move it somewhere here, so it responds very well. One module was died because I did not control a motor. The second one I connected with incorrect polarity, and this was died. So the third one survived, which I did all the tests. Make sure to connect this diode here between the positive and negative terminal at these 2 points, otherwise your motor will damage this. Thank you for watching. This was how to use this WH532 motor controller. Please make sure to subscribe by clicking at the subscribe button in here. Thank you. In this tutorial, we are going to control 2 DC motors using ESP32 over Wi-Fi with L298N module with RoboJax library. Let's start the motor. This is just controlling one motor. Speed up, change the direction of rotation. And now let's start motor 2. Direction of rotation of motor 2. Direction of rotation of motor 1. And to control it using your mobile device, USB is not connected.